Everything in the universe is in motion, from the frantic spin of subatomic particles to the elegant rotation of the Earth on its axis. Angular momentum is a fundamental property of the physical world. We see it in the way our moon orbits our planet, how the planets dance around the sun, and how our entire solar system spirals around the center of the Milky Way. For a long time, scientists believed this rotation had an upper limit, that once you reached the scale of the cosmic web, the largest known structure in existence, the motion would simply stop, replaced by a static, uniform expansion. But a groundbreaking discovery has shattered this assumption. Astronomers have found evidence of rotation on a scale so vast it defies conventional intuition. Cosmic filaments, the gargantuan threads of matter that link the universe together, are spinning. This isn't just a minor wobble, it is an organized, coherent rotation spanning hundreds of millions of light years, representing the largest rotating structures ever identified in the known history of science. To understand this discovery, we must first visualize the cosmic web. Imagine a cosmic tapestry, a network of interconnected highways made of dark matter and hydrogen gas. These are the filaments. They are the skeleton of the universe, and at their intersections, we find massive clusters of galaxies huddling together like bright cities at a crossroad. For billions of years, these filaments have acted as conduits, funneling matter into the dense clusters to fuel the birth of new stars. Until now, we viewed these filaments as simple, stationary bridges, passive structures shaped solely by the pull of gravity. However, new data suggests they are far more dynamic. By studying the motion of galaxies within these filaments, researchers have observed a distinct pattern. Galaxies on one side of the filament are moving toward us, while those on the other side are moving away. This is the unmistakable signature of rotation, a cosmic carousel of unimaginable proportions that challenges our very definition of large-scale structure. The discovery was spearheaded by a team at the Leibniz Institute for Astrophysics Potsdam using data from the Sloan Digital Sky Survey. Analyzing the light from over 200,000 galaxies, the researchers looked for infinitesimal shifts in color. Through a process known as Doppler mapping, they identified the redshift and blueshift of light emanating from the galaxies embedded within these cosmic threads. Redshift occurs when an object moves away from the observer, stretching the light waves, while blueshift happens as an object approaches. By meticulously mapping these shifts across the diameter of the filaments, the team confirmed that the galaxies were not just drifting randomly, they were caught in a massive, swirling vortex. These filaments, some reaching lengths of over 240 million light-years, are spinning at speeds of hundreds of thousands of kilometers per hour. This finding suggests that even on the grandest scales imaginable, the universe retains a memory of its initial conditions and the forces that set everything in motion. Why does this rotation matter? In the Standard Model of Cosmology, the early universe was thought to be remarkably smooth, with only tiny fluctuations in density. As gravity took over, these fluctuations grew, pulling matter together to form the stars and galaxies we see today. But gravity alone doesn't naturally produce such massive, organized rotation across such enormous distances. The discovery of spinning filaments implies that there is a mechanism for generating angular momentum on scales that we previously thought were dominated by linear expansion. Scientists call this torsional motion. It suggests that as matter was pulled into these filaments from the surrounding voids, the shear force of the collapse generated a shear, a twisting motion, that set the entire structure spinning. This discovery is a missing piece of the puzzle in understanding how the universe evolved from a hot, dense soup into the complex, structured web of light and dark that we observe through our telescopes today. The scale of this rotation is almost impossible to grasp. If you were to travel at the speed of light, it would take you hundreds of millions of years just to cross the diameter of one of these rotating filaments. Yet, despite their size, they obey the same physical principles as a whirlpool in a kitchen sink or a hurricane in Earth's atmosphere. This is the beauty of physics. The same laws apply from the microscopic to the macroscopic. By discovering rotation in the cosmic web, we are learning that the universe is far more interconnected than we ever dreamed. The spin of a filament affects the spin of the galaxies within it, which in turn influences the orientation of the stars and solar systems within those galaxies. We are part of a nested series of rotating systems, each one contained within a larger, more ancient motion. This discovery forces us to look at the universe not as a collection of isolated objects, but as a single fluid-like entity governed by the complex interplay of gravity and momentum. One of the most intriguing aspects of this discovery is the role of dark matter. Dark matter makes up about 85% of the total matter in the universe, and it is the primary constituent of the cosmic filaments. Because dark matter doesn't emit light, we cannot see it directly. We can only infer its presence through its gravitational effects on visible matter. The fact that these filaments are rotating suggests that dark matter itself is involved in this massive swirling motion. This provides astronomers with a new tool to study the properties of dark matter. By measuring the strength and speed of the rotation, researchers can calculate the mass and density of the hidden dark matter scaffolding. This dark spin might hold the key to understanding the nature of the invisible particles that dominate our cosmos, offering a rare glimpse into the shadows where most of the universe's secrets are hidden. This discovery also raises profound questions about the cosmological principle. This principle is the foundation of modern astronomy, stating that on a large enough scale, the universe is both isotropic and homogeneous, meaning it looks the same in every direction and is made of the same stuff everywhere. However, if the universe's largest structures are all rotating in specific directions, it might suggest a level of organization or a preferred direction that the Standard Model doesn't fully account for. Is the entire universe spinning? Probably not, but the existence of these rotating filaments proves that local anisotropies, areas where the universe is not perfectly uniform, can exist on much larger scales than we thought possible. Every time we think we have the universe figured out, it reveals a new layer of complexity, reminding us that our journey of discovery is only just beginning. As we gaze into the night sky, we are looking at a masterpiece of motion. We are inhabitants of a planet that spins, orbiting a star that spins, inside a galaxy that spins, all of which are embedded in a cosmic filament that is also, miraculously, spinning. The discovery of the largest rotating structure in the known universe is more than just a data point in an astrophysics journal. It is a testament to the human spirit's ability to peer into the darkness and find order in the chaos. It reminds us that no matter how small we feel, we are part of a grand celestial dance that has been unfolding for 13.8 billion years. As telescopes become more powerful and our models more refined, who knows what other motions we will find? For now, we stand in awe of the cosmic carousel, a spinning web of light and shadow that spans the infinity of space and time.